Good afternoon, everyone. Are you able to hear my voice? Start out. Okay, please reply in the chat box. Okay, are you able to hear my voice? Okay. Okay, within few minutes we will start the class. Okay, I'm not speaking anything. Okay, today we are going to see a new topic. Before going to see about new topic, now let us refer what we had learned till now. Now let us see. So this is a topic. I'm going to give the introduction part of this topic. So the topic is the remaining last topic of this unit. Now introduction. Okay, just I'm giving the introduction for this topic. So here we need to find the polar coordinates and how we are going to give the Newton second law in polar coordinates. Okay, that is the thing we are going to see. I will give the introduction for the topic today. And before going to see about this topic, let us refer what we had learned till now. I think now you are getting my voice. 103. Okay, we are referring to the unit number 1, mechanics. Now till now what we had studied, that we will just refer for few minutes and thereafter we will continue. Now let me check. I need to open this one in another format. తక్కువ మంది జాయిన్ అయ్యారు, ఇంకా కొంచెం వెయిటింగ్ చేశాను అనమాట. చేర్చు. Okay, now this is the thing. Now till now we had learned about quantum the mechanics here. Now just I will give the repetition of the topics just for few minutes. Thereafter we will continue with the introduction of the last topic. Now this is unit number 1. We are referring to the unit number 1. Okay, this is unit number 1, mechanics. Now here what we had started, we started with scalars and vectors. So we had given the introduction about scalars and vectors. Now we defined what is a scalar. We had given examples. Okay. Now quantities are the physical quantities. The physical quantities which possess only magnitude and not having any direction. So those quantities we are considering it as a scalars. Now here we had given certain examples. Okay. Thereafter we are considering the physical quantities depending on magnitude as well as on the direction. Okay. Now if the physical quantities having magnitude and direction, and if they are obeying parallelogram law or triangle law, so here we are considering parallelogram law. Okay. So physical quantities, okay, which are having magnitude, direction, and third condition is that they should obey the parallelogram law of vector addition. Okay. Now if these three things are there, then those physical quantities we are considering it as the vector quantities. Just wait. Okay. Now here we had given certain examples for that vectors. Okay, these are some of the examples we had seen earlier. Now next we had given introductory part for the addition of vectors. Now for the addition we are considering here two vectors. We had considered vector A. Okay, this is the first vector. Now second vector is continuing from the end of the first vector. Okay, this is vector B. And thereafter we are giving the result as this. Okay, this is the result of the two vectors. Okay, now we had given the result as R, which is also a vector, which is equal to the sum of the two vectors. Okay, this is the result of the addition of two vectors. Now in this case, here A is starting and ending with B. Now what we had considered here, we are starting with B and we are ending with A. Now the result is remaining same. The resultant vector is remaining same, even though these two are altered. Now that is the thing here. R is again same. Okay, that is regarding the vector addition. Now thereafter we had considered the subtraction part, subtraction of vectors. Okay, now here regarding the subtraction of vectors. Okay, now here this is vector A, this is vector A. Now here there was a confusion for few students. Now this is vector A here. Now this is in this direction. Now second vector is there which is coming back. What is the meaning here? You had started in this direction, you moved in this direction. Thereafter you are coming back with some other direction like this. Then you need to find where is the starting point and where is the ending point. Okay, so the distance will be reduced here. The distance between these starting and ending point will reduce. For suppose if we go with the addition will be like this. If you are going in this direction up to certain distance, and if you are moving in this direction like this, and you ended here, then what happens? The distance between the starting and the ending, okay, this will be larger. Okay, it is sum of the first two. Okay, this is larger here. What is the reason here? The two vectors are getting added. But in this case, what happens? As you are coming in the reverse direction, there is a subtraction part. Okay, that was the thing we had in the previous explanation. So here, that is the thing here. The resultant vector is given as A minus B bar. Okay, instead of minus, you can write the same thing as A plus, okay, the sum of the second vector, but it is in the opposite direction. So this was the explanation we had seen in the previous class. Okay, now the same thing, A minus B, we are writing it as A plus of minus B. Okay, you can write the subtraction as the addition also, but you need to have a minus sign. There is a minus sign here for the second vector. Now thereafter what we had seen, just wait. Okay, someone said screen is not visible, but actually screen is getting shared. Is there any other person getting the same disturbance? Screen sharing is continuing. Okay, still you are getting S means S for what? Are you getting the screen sharing or not? Don't say yes. You need to give what is S? S for getting screen sharing. Okay, okay. That's okay. That's okay. Someone said not getting screen sharing. You try to log off and try to re-log in. Then you will get the screen sharing. Okay, try once. Because other persons are getting the screen sharing. Okay, now let us refer to the next topic that we had studied in the previous class. Now the topic is regarding the resolution of vector. Okay, now we are going to resolve the vector. That is the topic here. We are going to resolve a vector. Now let us refer to the concept of resolution. What is the meaning of resolution? For that, what we had explained in the previous class means we are going to consider a vector. So now here, let me redraw the diagram. So this is a x-axis, this is y-axis. Okay. Now thereafter, we are considering a point is there, a point P. This is a reference point here. Now you are going to draw a line joining these origin. Let us consider this as origin. So this is going to give a direction. Okay. Arrow mark is direction, and this is the length here. So now here we are marking in this example as A. Okay. Now A is a vector here. So A is having a magnitude. What is the magnitude? It is starting at point O and ending at point P. So it might be some 1 kilometer, 2 kilometer, or whatever it may be, depending on the application. Now, what is the direction here? It is starting at point O and ending at P. So you are going to mark this like arrow mark. Okay. So what is this arrow mark here? We are going to start at point O. The point is starting at point O and it is ending at point P. So here you are getting the magnitude. So this is the magnitude here and you got a direction. You are moving in this direction. So this is a vector here. Now the topic is giving about the resolution. You need to know what is a resolution. That what we had explained here. Let me draw here. I am redrawing the same diagram here. Okay, this was the axis or the plane here, x and y plane. Now here you redraw the vector here. This is a vector. Okay. Now this is point P. This is point O. And here this is the vector A. Now what is the topic here? We are going to resolve the vector. You are going to resolve into two factors, other two quantities, two coordinates. Now what you are going to do? From here you draw a normal line. Okay, where the axis touches here, that is a intercept. You are going to get the x-intercept. So this will be the x-intercept. Okay, this is the x-intercept. Now similarly, you draw a normal line towards the y-axis, and here this is an intercept here. So this is again the y-intercept. So now you got two components. Two components you are going to get. Now the same thing here. The x component, this x component, we are going to write this as a x. Okay, x component of the vector A. Similarly, here the y component here, we are going to write this as a suffix y. Okay, y component of vector A. Whatever the vector is there, that we are going to resolve into two components. So why you are getting two components means you are considering xy plane. Okay, x-axis and y-axis. Okay, so that's why you are getting two components here. If you take three-dimensional, if you take the z-axis also, then you will get the three-dimensional, that is three components. So in this diagram, it is a two-dimensional diagram. So you are considering xy plane. Okay, so that's why you are going to get ax and ay, only two components you are going to get. So now what is the result you had seen in this topic? The resultant vector A can be given as the sum of the two components. Sum of the two components. So what actually this, what is the importance of this means? I will give one more explanation here. Now here, let us go with another diagram. What is the resolution of a vector? For that one, I will give one more explanation. General explanation here. Now consider, you might have seen a point will be there marking with 3,3 or 2,2. Okay, like this. Okay, something you might have seen in your intermediate. Now what actually this particular thing, this states that this particular point. Okay, so I'm going to give the explanation here. What is the thing of resolution? Now what is the thing means, you take the axis. Okay, take the axis, x-axis, and here this has a y-axis. Now a person is there starting at point O. Now he is moving some 3 units distance. He moved some 3 units distance. Okay, 1, 2, and 3. 3 units on the x-axis. Now from this point, okay, after reaching the 3 units along x-axis, he deviated towards y-axis. Okay, and he again moved some 3 units distance. Okay, 1, 2, 3 units along y-axis. Okay, so that's why this particular point will have the coordinates 3, 3. Okay, now this we are going to join like this. We are going to join like this. Okay, now that is the thing here. So instead of all these things 1, 2, 3 and like this, we are going to give a common thing here. We are going to give a common thing. Okay, now see, instead of writing all these notations, we are going to write only the vector components. Okay, you take point P and you mark 3, 3. Okay, this has O, this has x-axis here, this has y-axis. So now the same thing here, you can write the position of the vector. This particular point can be written like this. Some position r can be given as, you might have seen this equation also, some xi cap plus yj cap. This equation you might have seen. Now if you got 3, 3, the same thing you can write like this. This has 3i plus 3j. Now what is the meaning of this? This is the position of the vector p at this particular point. What you can say? You can say that you are going to move 3 units along x-axis. This represents the x-axis. And from there, you will turn towards y-axis and you will move 3 units. Okay, regarding the y-axis. Now, simply if I mention with some other example, let us go with another example here. Example, okay. If I give directly, you point a object, okay. This is a question I am giving. Then how you are going to solve? You point a object which is located at, okay, located at some phi I. Let me do like this. Some 5 comma 5 comma 6. Okay, in xy plane. In xy plane. Okay, this will be the question. If I ask a question like this, okay, then what you will do? You need to draw just a simple graph. You need to draw a simple graph. Let me go here. I will draw here. Okay, but this I'm writing like this. Now here you draw a graph xy. Okay, this is xy here. Now what you will do? What I mentioned here, you need to find a point or an object, okay, located at 5 comma 6. Then you will start at point O and you move. Let me mark like this: 1, 2, 3, 4, 5, 6. Okay, na? Next here also 1, 2, 3, 4, 5, 6. You write the numbers like this. Okay. Now here what we mentioned here, we are moving 5 units along x-axis. Okay. Now thereafter you are moving along 6 units along y direction. So from origin O, you start moving like this and you reach 5 units along x-axis. Now after reaching the point 5 or this particular point, which is at 5 units away from the origin, from there you turn towards y direction and you start moving. Okay, you start moving. So how much you are going to move here? You count here: 1, 2, 3, 4, 5, and 6. Okay, so from after reaching this particular point 6, okay, you stop there itself. Okay, now what is the thing here? You moved 5 units along x direction and thereafter you turned and you moved 6 units along y direction. Then this is the final position here. Okay, now this is going to be the vector, the resultant vector. Okay, so that we had wrote as a bar. Okay, so now here this is point P. Mark this as point P, and here the coordinates, you can mark the coordinates as 5 comma 6. Okay, like this you are going to understand depending on the explanations. Okay, now instead of 5 comma 6, we are going to give the coordinates like this: x coordinate and y coordinate. Okay, so this is the thing you need to understand regarding the resolution of vectors. So what is the thing here? The vector A, okay, is there on x-axis here, how many units away from the x-axis, or from the origin towards the x-axis, and here how many units away from the origin towards y-axis. So those things you are going to resolve. Okay, now regarding the same topic, you might have seen the angle here. If you want to take this as the angle here, theta. Okay, now again you can refer back to the previous explanation here. This particular tan theta can be given as
the y component. Simply you might have studied here some cos theta equals to x by r. Next sin theta equals to y by r. Okay, from tan theta what you are going to write? You are going to write this as some y by r. Okay, you substitute these factors, okay, these factors, then what you are going to get, sorry, 1 y by x, you are going to get this as y by x. Now instead of y, what you are writing? The y component of a. Okay, instead of x, what you are writing? You are writing the x component of a. The same simple substitution depending on your previous studies. Okay, just we have repeated the things. Now that was the topic that we had studied in the resolution of vectors. Now thereafter we had studied about the transformation of scalars and vectors under rotation. Now here what we had studied, the same topic. The topic is having transformation. This is a concept, transformation. Okay. So what we are going to transform, there we are going to verify separately about scalars and vectors. Okay. Now what is the thing here? We are going to have the rotation here. We are going to have the rotation. So if you rotate the things, how the scalars are going to be transformed, whether they are going to be transformed or not. Is there any change or not? Similarly, vectors are going to be transformed or not. That we are going to verify here. Now there we got a simple thing. The first part we are going to deal about the scalar. Okay, this is the first part here. First part, okay, of the same topic. Now here we are going to define about the scalar or verify about the scalar. Now what is the result here? What we had seen with some example. We had considered example here. So what is the point here? We need to verify about the scalar here. Okay. Now for a scalar, we are going to verify here. Now this is without rotation. Thereafter, this is about the rotation here. Under rotation here. This is rotation here. Under rotation. Okay. Under rotation here. So you compare the first and the second diagram. Now what we had compared between these two diagrams. Okay. Now what is the thing here? This is a origin here and this is the xy plane here. Okay. Now you started moving on the x-axis. You moved up to 800 meters. After reaching 800 meters, you move towards y direction up to a certain distance of 600 meters. Okay. Now this is the end point. Okay. This is a starting point here and this is the end point here. Now what is the distance between these two? Okay. This you can obtain by means of the previous explanation. Now if this is a triangle, which is a right angle triangle here. Okay. Now if this is some theta, this is going to give the hypotenuse. Okay, hypotenuse depending on your previous study. So the same process here we can apply here and you can find what is the magnitude of this hypotenuse, or you are going to define a vector, some vector a. Okay, either you can take anything. Okay, so if you consider this as a vector, you mark this as a bar like this. Okay, now here what is the thing you obtained here? By taking this root 800 square plus 600 square, what you are going to get? You are going to get the magnitude. Now what was the result you got in the explanation? Okay, let us see here the same explanation I had mentioned here. Assume a car, okay, moving 800 meters in magnitude along x-axis. Okay, next from there it moved 600 meters along y-axis. Okay, now what is the result or the resultant displacement here? The resultant displacement is 1000 meters. Okay, how you got this as 1000? You substitute the values here. You substitute the values. Okay, like this. So here the result is 1000 meters. Okay, so this was the comparison without rotation. So this was without rotation. Now the same thing here. second person has started here. Second person started here and he moved in other direction like this. Okay. Now if you compare the first process and the second process, if you consider this as the first process, you consider this as X. Okay, XY plane. Now the second person moved in another path or in another plane. This as X prime, Y prime. Okay. Now you compare here. He moved up to certain distance here. Okay. Thereafter he reached this point here. The same point he had reached. The same point, whatever the point you are reaching there, the same point the second person reached with another path. He followed another path. Now here what should be the distance? It should be again 1000 meters. What is the reason? What I mentioned here? The second person is also reaching the same destination. Okay, so that's why this particular resultant displacement between these 2 points is remaining same. But he is following the second path. So even though the path is varying, okay, so here under what variation here? It is under rotation, some theta. With some angle theta, you got this particular geometry. So if the second frame is rotated with an angle theta, the resultant path is remaining same. Okay, so that's why the scalar quantity, this is a scalar quantity. The displacement here, it is a scalar quantity. So the scalar quantity is remaining same in both the conditions. Okay, so here this particular thing is the 1000 meters and here also 1000 meters. So this value is not changing even though there is some rotation. So that's why what is the conclusion of this particular scalar under rotation? You will conclude that even though the scalar is rotated, okay, there is no change. Okay, that is the thing you are considering is the conclusion here. So here regarding the conclusion of the scalar, what is the conclusion here? The scalar quantity remains unchanged. It is going to be remaining unchanged. There will be no change even though the frame is rotated. Okay, so what is the first part here of the topic? Transformation of scalars. Okay, so here what is the result here? The scalars are remaining unchanged. Okay, this is unchanged. Now what is the second part? We are going to see about the vector. Now what is the vector here? You refer back to the diagram here. The same diagram with certain additional geometry. You need to add certain things. Now what we are adding here? We are adding certain things. So here you find the distance between the origin. Okay, this is origin. And here the point where the second person has deviated. Okay, he reached this particular point. From here he diverted in this direction. Okay, so you need to find this distance as x dash or x prime. Now from there he deviated and he moved towards the y direction. So you find the y dash or y prime here. Okay, previously you moved in this path. You moved in this path. So this distance as x here. So x here regarding the first person and here the x prime regarding the second person. Now similarly, the first person magnitude is y and here the second person magnitude is y prime. So you need to find the relation between x and x prime. Second one, y and y prime. Okay, what is the reason? The first person is moving in xy frame. Now what is the second person moving? He is moving in like this, x prime, y prime. Okay, if you compare both the frames, what you are getting? If this is xy frame, okay, now second person is moving in this direction like this. This is x prime, y prime. Now what is the angle between these two? It is theta. Okay, so you need to find the relation between these. Okay, x prime, y prime. Okay, so that we had seen. So using the geometry, simple geometry, okay, you can find x prime. So what is x prime here? From point O, you are starting at point O and you are ending at point B prime. Okay, B prime here. So the same thing here, you are starting at point O here and you are ending at point B prime. Okay, and in between you got this particular point C prime. C prime is also there. Okay, C prime is also there. So what you can write here, it is the addition of OC prime plus C prime B prime. Now you apply the geometry, you will find the triangles. Okay, you find what are the triangles available. Find this factor. Find this factor. Okay, now again apply the geometry. You find this factor. Okay, that we had seen in the previous classes. Okay, you will get this particular factor. So here this is the C prime B prime. Okay, again apply the geometry using these two triangles. Okay, use these two triangles and find the factors. Okay, add these two. You add these two. Okay, you add these two. Okay, now what is the result you are going to get? So remember, we had seen all these things. Just I am giving the revision of the topics what we had learned. Okay. Now from there you are going to get x prime here. This is x prime. Now similarly, you had referred to the second diagram. Okay. This diagram is for y prime. Okay. To find the y prime here. Now the previous diagram, using this diagram, you are going to find the x prime factor. You are going to find x prime using this diagram. Okay. To avoid confusion, I had redrawn the same diagram. With certain other geometry. To find y prime, you can consider this diagram separately. Same diagram with certain geometry is there. Okay. Now apply the same mathematical or the geometry here. You find okay the result. Okay. So then you will get the resultant equation. Okay. Now this is the resultant coordinates y prime and x prime. So that was the thing. Now you had substituted simple thing here. Previously we had substituted x and the component of a as ax. Now y as y component of a. Now here what we are going to do, x prime component we will write this as ax prime and y prime component we are going to write this as ay prime. Okay, simple substitution we are doing. Okay, what is the meaning here? You got x here and here y. Okay, simply you replace this factor here. Okay, simply you replace this factor here. Okay, then the same equation here, this has this particular x prime as ax prime. Okay, now what is the equation here? Ax prime. Okay, this is the thing, ax prime will be equal to ax. Okay, in substitution here, just substitution, x is to be replaced with ax. Okay, so cos theta as it is. Okay, next y will be replaced by ay. Next sin theta as it is. Okay, these things we had seen in the previous class, previous explanations, whatever the day was there. On that day we had seen all these things. Now from there, what was the conclusion of the topic regarding vectors? We are going to get a change in the vector. So that's why what is the thing here? The components of a vector. Okay, the components of a vector are transformed or changed here. Okay, but the scalar quantity that was previously seen, that was remaining same. Now here, this is the two-dimensional explanation. We are considering x, y, x prime, y prime plane. Now if you consider the third axis like this, then what happens to the third component? That is the thing here regarding third component. So both the components are remaining same. Both the components are remaining same. What is the reason here? If you consider the plane is there like this, okay, second plane will be somewhat like this. Somewhat I had rotated the second plane like this. Okay, but here the perpendicular component is remaining same. If this is x and this is y, this is z. Okay, for the first plane, if this is the first plane here, okay, second plane has been rotated. Second plane has been rotated here. Okay, but the axis here, the z-axis is common for both the planes. So that's why there is no change regarding the third dimension. So for the x prime, y prime, the third axis is az prime. Similarly, for x and y, this is the z component. So both the components are remaining same. What is the reason? The z axis is not changing. It is remaining constant. So these were the things that we had seen. So there were the mathematical things that were explained. Now thereafter we had seen different types of forces that are available in nature. Okay, there we had seen 4 types of forces. Okay, gravitational, next electromagnetic, strong nuclear force, weak nuclear force. There we had explained with short explanations, not too heavy is required, just to give what are the things going on regarding these 4 forces. Okay, that we had seen with some short mathematics. Okay, the representations here regarding the equations. These things are enough. Okay, we are not going to deal much about these types of forces. Now those 4 forces you can write with a short notes. Thereafter we had seen about the Newton's laws. Okay, Newton's laws, you know what are the 3 laws available that we had seen in the previous classes. Okay, now here the first law that we had mentioned. First law, what was the first law statement here? If a body is at rest, it will remain at rest. Okay, there will be no change. If a body is moving with some uniform velocity, it will continue as it is. Okay, until some external force acts on it. Okay, that was explained with some example. If you are considering a football is there, it will remain stationary on the ground without any change. When you apply a force on the football, then only it will move depending on the direction of force. Okay, similarly, what was the second thing here? If an object is moving with some velocity v, it will continue with the same velocity. If you apply some external force, then you will have a change here and it will move either fast or slow. Okay, the same thing here, the statement, if a particle or an object is at rest means it will remain at rest, and if it is moving at with the uniform motion means it will continue to be in that state. Only if there is an force acting on it, then only there will be a change in that particular state. So that was explained in the Newton's first law, and Newton's first law can also be stated as law of inertia. Okay, inertia means inert, there is no change. Okay, inert, you might have seen inert gases. Okay, the same thing here, inert means there is no change. Okay, the same thing here, we call it as the Newton's first law or else law of inertia. Now thereafter we had seen about inertial frames. Inertial frames, okay, the reference frame. Thereafter we had seen the comparison for the second law and third law. and we had seen the mathematical oriented topic, form invariance of Newton's second law. Invariance, nothing but no change. The second law is not going to be changed. Under what conditions? If there is a comparison here, if you consider the second frame, if it is moving, the second frame is moving with some velocity. Okay, what was the velocity that was mentioned? It is moving with some constant velocity. Okay, it is moving constantly away from the first frame. With that comparison, we had seen the origin here. Okay, the origin O, and here the origin O of the second frame. Okay, thereafter from the origin we had considering a particular point P. Okay, thereafter we had seen the comparison here, and we had found x prime, y prime, z prime components of the second frame, particle in the second frame. Thereafter what we had seen, the velocity, okay, and acceleration. Okay, you started with the x component, you found the values of x prime. Thereafter you got velocity, which is equals to dx prime by dt. Okay, thereafter you got the acceleration, this is equals to du by dt. So these were the things. First you find the position of the particle, okay, in the first frame. Now position of the particle in the second frame. Now you can find the velocity of the particle in the second frame, or you can mark like this, x prime here. Thereafter you can find the acceleration, okay, of that particular particle in the second frame. Now what was the conclusion here? So you can find all these complete explanations that were recorded. You can find the link that I had shared in the group also, I think. If you want, I can share the same link for those particular recordings, video recordings. Now these were the things. We call these four as the Caylenian transformations. Just I am giving the concepts what we had learned till now. Okay, from there what we had concluded, we will get a conclusion that f prime is equal to f. What is the conclusion of the topic here? The force in the first frame is also equal to the force in the second frame. So both the forces are remaining same. Even the frame is moving, the second frame is moving here, the force experienced in this particular frame is remaining same as that of the first frame. So there is no change in the second law. So here if you can see f equals to ma, that we are giving f equals to ma. This is equal to what you are going to get as ma prime. So both the forces are remaining same. So here that was the conclusion. It is invariant. The second law is invariant between the frames. So there we had stopped, okay, with some equation of particle. So here you are writing the same thing as the equation here. Okay, f equals to ma. A can be written like this. Okay, second derivative of the position. So what you have started, you started with the position. Thereafter u equals to dx by dt and a equals to du by dt. This can be given as dx square by dt. So if you go with the f equals to ma, what you can write here, you substitute this factor here, substitute factor here. Then what happens? This equals to m into t square x by dt square. Okay, so here this is the second derivative. Okay, So here we consider this as an equation in the second derivative. So we consider this as the equation of motion of the particle. So there we have stopped. Okay. Now let me give the introduction for the next topic that is remaining at the end of the unit. Okay. So what was the topic here? Let us see. Okay, the remaining topic here, Newton's second law. Okay, we have to obtain this in terms of polar coordinates. Polar coordinates. So this is the topic remaining. Okay, in the first unit. Okay, now just I will give the short introduction of the topic. Now for that I will try to take some images, or let me give the here a small diagram here. Now previously you had seen this diagram. XY plane is there, a particle P is there. Okay, this is the origin. Now you are marking this as r cap or r, okay, the position here, or a vector, and from there you are going to get y component, and here this has the x component. So this you had seen in the previous explanations. Okay, now here what we are going to refer regarding polar coordinates. Polar coordinates. Okay, now here let us take a circle. I will repeat the same points in the next class also. Now let us take a circle. Now consider this as the origin. X and Y is a plane here. Consider this as a point P. Okay. Now here, now what is R? Let us identify what is R here. Okay. Now what is the thing I had considered here? First I started with a circle. Okay. This is a circle here. On the circle I had pointed point P. Now the question remains, what is R? So R becomes the radius of the circle. Now here you need to identify here some R is there. So if you consider a circle, it is a radius. Now if you consider point P, it is going to give the position of point P. It gives the position of point P. R gives the information about the position of point P. Now here, second point you need to identify. What is the angle between x-axis and this particular point? Okay. This we are going to write this as theta or phi. Let us take this as phi. Okay, you can take anything. Okay, so now we are going to give x as r as the position of the vector. Okay, or the position of the point here, and theta or phi as the angle between the vector and the axis of, or let us take this as the x-axis and the x-axis. Okay, so now here what is the what are the coordinates you can write for point P? You will write this as x comma y. Now we are considering this as the rectangular coordinates or Cartesian coordinates. This was the previous thing we had seen. Coordinate system, you can consider this as a coordinate system here. Okay, this is only an introduction of the topic. Okay, now here what we are going to do here, we are going to give the coordinates as r comma phi. You compare here, we had given x comma y here. Now here we are going to give r comma phi, or you can take this as theta also. You can take anything here. Okay, you can take theta or phi. What is that? It is representing the angle between the vector that was formed and the axis, x-axis. Consider x-axis only. Okay, so now we are going to see the entire topic depending on this particular coordinate system. This is known as a polar coordinate system here. Okay, so I'm repeating here. You take the x-axis and y-axis. Okay, find point P. Okay, next what you did here, you identify the origin as O. From there you had drawn a line like this. Okay, now you identify this as a position vector here. Now you identify the angle here as some theta or phi, anything. Okay, now here what are the coordinates we are going to refer? For point P, we are going to take r comma theta as the coordinates. So depending on this concept, we are going to see the topic. What is the topic name here? We need to find the Newton's second law. Okay, in terms of polar coordinates. What are the polar coordinates here? R comma theta or r comma phi in this particular concept. So now how many dimensions we are considering? This is only a two-dimensional case. Two-dimensional case. So why I am mentioning this as two-dimension? Because we are considering only x-axis and y-axis. We are not mentioning the z-axis. So that's why you are considering this as a two-dimensional case of study. Okay. Now regarding x and y, so here you got x component or the x coordinate and y coordinate. Now here instead of those we are going to get this as r and theta. So now here depending on r theta or r comma theta, we are going to have a mathematical part, and from there we need to get the expression for the Newton's second law. What is Newton's second law? F is equal to ma. So m is a scalar quantity. So wherever m is there, you will write m as it is. But you need to find a in terms of r and theta. Okay. So those things we are going to verify, and we need to give the resultant equation of the Newton's second law or the force. Okay. So this particular force we are going to give in terms of r and theta. Okay. Now those are the things we are going to verify in the next class. Now let me give few more points here. Okay, what are the extra things you need to identify? No, okay, I'm repeating the same points here and I will add few more points. Okay, so what is the topic we are going to see? Newton's second law. Okay, in polar coordinates. Polar coordinates. So this is the topic name. Okay. Now for that, what we had started, we are considering a plane xy. Okay. Now you are considering a point P in this particular plane. Consider this as point P. Now you find the position, okay, of this particular point from point O. You mark this as the position vector. Okay. And you find the angle between the x-axis and this vector as theta. Okay. then what are the coordinates of the point? It will be r comma theta. Okay. Now, this is the first point, first important point of this topic. Second point, if suppose if I go with x, okay, so we are not going to refer about x, y, z, okay, but just for comparison to understand, okay, if x is there, x is the position. If x gives the position, what is the velocity? How can you give the velocity? Velocity can be given as rate of change of the displacement. So v is the representation which can be given as dx by dt. Okay. Now, how can you give the acceleration? Acceleration you are denoting it as a. How can you write the acceleration here? dv by dt. Okay. So now you substitute v here. Substitute v here. So what is v? V is dx by dt. Then what happens? You can write this as d by dt into dx by dt. Okay. Now what you can write like this? You can write d square x by dt square. Okay. Now here we are going to have a new notation. So instead of dx by dt, I will write this as x dot. Okay. Now here d square x by dt, I will write this as x double dot. Okay. So this particular dot means it is the first order derivation. If you are having two dots means it is second order derivation. Okay. So these notations we are going to see in this topic. Okay. If I write r dot, what is the meaning? It is r dr by dt. If I write r double dot, then what is the meaning here? It is equal to d square r by dt square. So for single order or the first order, you will get dr by dt. For second order, okay, you are going to get double dot. Okay, so you need to identify here. We are going to see dots on the notation. Now, if suppose theta dot is there means, what is the meaning theta dot means? It is d theta by dt. If there is theta double dot, there is double dot here, then what is the thing here? You need to consider this as d square theta by dt square. Okay, so these notations we are going to see in the upcoming derivation. So this is an introductory part of the topic. Okay, so what is the topic here? Find the Newton's second law in polar coordinates. For that you are considering the point P and the coordinates will be r comma theta. From there you need to find position, velocity, acceleration. Okay, so now here we are going to get the values in terms of r comma theta. We are not going to see about x. Okay, we are not going to see about x. We are going to see the r values and theta values. Okay, depending on those r and theta, we are going to find the expression of acceleration. We will find the acceleration. Okay, and we will substitute that acceleration in f equals to ma. A means acceleration. So you will find the acceleration in terms of r and theta, and that will be substituted here. Then you are going to give the expression in terms of polar coordinates. So these things we are going to see in the next class, that is tomorrow. Please be online. If you are having any doubts, you can raise your hands. Okay, for attendance only, I said please be online.